soil and the rocks, and then also in the atmosphere itself. And then now with the Atlas V that we have, it launched the Curiosity rover in 2011, as well as 3 other Mars missions in the last 15 years. And so now here we are with the Atlas V for Mars 2020.
So I imagine there are a lot of parts to the rocket, and you have to assemble them there at the Cape?
Yes, that's correct. So the booster comes to the Atlas Spaceflight Operations Center, or ASOC, goes through initial receiving, inspection, and testing, and then it gets transported out to the Vertical Integration Facility, or VIF, and erected onto our mobile launch platform. The solid rocket boosters are our next step. For this mission, like I said, we'll have 4 solid rocket boosters. They come down from Camp Blanding, Florida, and they're hoisted and mated to the booster. Our Centaur, like the booster, comes to the ASOC first for the initial receiving, inspection, and testing, but then it actually gets moved over to our Delta Operations Center, or DOC, for vertical integration with the boat tail components and the base module. And then that vertical stack as a whole all gets transported over to the VIF and hoisted on top of the booster. Our last piece that we have is the payload. Our payload goes through final processing and encapsulation at one of our different payload facilities, and then it gets transported over to the VIF and hoisted on top. For this mission with a 68-foot payload fairing, after all of that's complete, we're actually standing at 197 feet tall.
Tell you what, it's very exciting. We're very excited for Countdown, but more importantly for you guys, another successful ULA launch to Mars. We wish you the best, and thanks so much for coming on the show.
Yeah, thank you very much. We're really excited. ULA, 139 straight successful missions, and just really excited for this one to be our 140th mission.
What can you say, Franklin? ULA has quite a track record when it comes to these Mars missions, and I tell you, in about 72 hours, and certainly by the time Perseverance lands in February, I expect ULA will have built upon that legacy with another successful launch.
Yes, and as we build toward that launch coming up on Thursday, let's take a look at the pad right now to see whether or not a rollout has started. You can see the rocket in the structure there, but word from Mick Waltman from LSP says that the rollout is about 10 to 15 minutes behind. So we'll move on in our show and come back to Mick at the pad in a few minutes. But when you talk about the LSP and the launch team and getting rockets and missions like this off the ground, one of the most important people that you want to actually talk about and know about is the launch director. And Blair had an opportunity to sit down with Omar Baez to talk about his job as the Perseverance launch director.
Hey Omar, thanks so much for joining us on the show today.
Well, thank you for having us.
I tell you, I'm really excited about Mars 2020, and what I'm wondering is, from a launch services perspective, I know all launches are important, but when you have a mission to Mars, like Mars 2020 or Perseverance, what are some of the unique challenges you guys face?
So we always do have some challenges regardless of the mission. The Mars missions, the Mars landers or the rovers take a little bit more effort. For example, for the rover missions, basically the rover has to get assembled here along with the crew stays, aero shield. It's got to get fueled here. So everything comes in pieces. It's not a fully assembled satellite. It just needs to be fueled and checked out and encapsulated and go out to the launch pad. So the Mars 2020 mission, parts started arriving in December, January. So we're talking a 7-8 month effort to put it all together here. That's different in of itself. There's other complexities too with the Mars 2020 mission. We have RTG, which is a nuclear power source for the rover. We've got to take some extra safety measures, some extra controls, and some care when we're dealing with that kind of material to make sure that we're safe and that the public is safe in the end. So it's very special to us. We know that it's difficult. We know other countries have had a hard time doing it. We've been lucky in the last 10, 15 years with our Mars missions in that we were able to actually get to Mars, land, and operate. Some other countries have not had the luck we've had. So yes, we're excited, and COVID has placed a heck of a burden on us to get through this. So it lives up to its name, Perseverance, and we're living it every day.
Well, you bring up a good point. I mean, you start talking about the assembly of the satellite back in December. That's before all the COVID stuff came about. And yet the launch window to get to Mars is fixed. So really hats off to the entire team for putting in the hours and effort under these conditions to get ready for this launch date.
Yeah, it's been quite the learning experience, and we learn from every mission that's gone on, even if it's not a launch services program mission, even if it's not with United Launch Alliance. Those missions that we have some insight into, or that they use our facilities, we've learned how to live with the threat of COVID, from the spacing to the hand cleaning, the mask wearing, to setting up remote control conference centers so that we're able to space out our folks that would normally work a mission into a setting where they're not on top of each other doing the work. There's some areas where we can't avoid that, such as the prime control room, but we enforce all kinds of health checking with temperature checking before you go into the facility, mask wearing all the time. So it's been quite the learning experience for the whole program and the agency.
Now, one final question I have for you. We know your partner in crime, your fellow launch director, Tim, aka Jim Dunn, and I'm wondering, how do you guys determine who gets what mission? I mean, I'm sure you both, do you arm wrestle? Do you do rock, paper, scissors? Because I'm sure you both were very excited about Mars 2020.
You could say we arm wrestle. No, it's just a toss of the coin. It depends on our load. He also had a personal event. He's got one of his kids getting married in April of next year, and so we swapped missions so that he would be able to go do that. So there's nothing scientific about it. There's no hand wrestling. It's a flip of the coin. We go eeny, meeny, miny, moe, and pick our missions.
Awesome. Well, you both do a great job, and we're looking forward to a successful mission. Best of luck to you and Mars 2020 and the entire team down there in Florida. Looking forward to a great rollout and wish you guys the best.
Thank you.
Well, as you can imagine, Franklin, we've been part of many launches, many rollouts. It's inevitable that we run into the delays, and it looks like there's a delay for the rollout, slight. We don't know how long, but fortunately we have Mick Waltman on the phone with us, who's going to give us an update on what's happening out there in the heat. Mick, how are you doing?
I'm doing great, Blair. Thanks for having me this morning.
Yeah, can you give us an update on just basically what's going on? You may not have super details at this stage, but try to give us the flavor of the situation.
Yeah, the teams came in this morning early and started getting everything ready. They've got the decks in the vertical integration facility raised up, and the MLP is jacked up and on the trucks ready to go for move. However, they have run into a couple of minor issues that they're having to correct before they leave the VIF, or the vertical integration facility. So they're running about 10 minutes behind for tower roll this morning. But the team is on it, and everything is still looking good to get Mars Perseverance to the pad.
Hey, Mick, generally, how long does it take for the rollout to last from the VIF to the pad?
Between 20 and 30 minutes. We travel anywhere between 3 to 4 miles an hour with the mobile launch platform. Once we clear the vertical integration facility, they creep out of the VIF very slowly and then pick up speed to get into the pad. And once they're at the pad, they will then lower the MLP, or the mobile launch platform, down onto the jacks at Complex 41 here and start securing everything. And then the team has probably about 4 to 5 hours of work to get all the commodity lines and electrical lines hooked up, getting ready for tomorrow's launch.
And Mick,
or Thursday.
Yeah, and Mick, as I understand it, under normal circumstances, you roll out basically 24 hours before launch, and in this case, it's closer to 48. So, will this delay have any impact on the countdown progression as we move forward toward the launch?
No, Blair. Yes, you're correct. We normally do. However, for a planetary mission such as Mars, We build in a little extra time for RP1 tanking and a wet dress rehearsal test that we performed to test the vehicle out, which was done about a month ago. And because we do that test, we're able to leave the RP1 fuel in the first stage on board. So we do not have to fuel the rocket once we get to the pad as we normally would. The other thing it does, because it's planetary and because of the time of launch on Thursday, 7:50 a.m., the teams have to report on station at midnight. So what we try to do is build in a crew sync day prior to them coming on to station to give them enough time to rest, make sure they're focused and ready to perform launch countdown to provide mission success to our customer.
I'm sorry, Mick. You're going to have to repeat that entire answer because I was mesmerized by the incredible visuals of the drone footage we're seeing from the T-Rats team. Pretty amazing stuff. Just kidding. Go ahead, Franklin. I just it is pretty stunning what we're seeing here, even in the midst of a delay.
Yeah, and speaking of delays, Mick, throughout the agency, everybody's dealing with the COVID-19 quarantines. Has that impacted the progress of this mission in getting the, rollout done and the mission off the ground?
My answer would be no, Franklin. I will say it has definitely made us rethink how we do business. The teams at ULA and NASA have continued to process this launch vehicle and find new ways to be able to check it out and get it ready for the launch on Thursday. COVID has definitely provided us some challenges to make those things happen. But it has not delayed this mission in one bit from an aspect of trying to get things processed and moving forward.
And so I guess it's important to point out, Mick, at this point that, like you said earlier, the 48-hour time frame for the roll is entirely based on planetary missions and is not related to things like COVID. Everything pretty much is trying to maintain a regular schedule moving forward, right?
Yeah, absolutely. With the Mars mission especially, we have the launch period that we have to be able to launch Mars 2020, which started at July 17th and goes to August 15th. And so we have to pick an optimal time to be able to launch this vehicle. And we've picked the 30th to be able to do that, and we've got a 2-hour window on that day. So as you said, Blair, the teams have continued to follow their processes, follow their procedures. And we have had to find new ways to do certain things, but we've been able to do it. The teams have worked very well to get this rocket ready for launch on Thursday.
Now, Mick, once the rocket gets to the pad, what would be the next process that would take place to prepare it for launch?
Hey, hang on, Mick, before you answer that question, I just a little a public service announcement. We have to leave our coverage with NASA television. We're going to continue covering the event on our social media pages, so stick around if you want to see the rollout as it starts. We're going to try to stay on and cover as much of the rollout as we can once we leave, but want everybody to know on NASA television, jump over to the social media pages, and don't forget to watch the launch on Thursday on NASA television as well. So stay on NASA Edge's YouTube channel and Facebook page for continued coverage, and thanks so much for watching on NASA television.
There's one thing that stands between us and the harsh environment of space: our atmosphere, the part of Earth that sustains all life. But here, in the closest town to the North Pole, it's slowly leaking away. A team headed there to launch rockets into the leak, but it's not the lack of atmosphere that they're concerned about. The leak is a natural process that will take billions of years, so we're not going to run out anytime soon. It's part of the larger story of how a planet's atmosphere changes over time, a key factor in the search for life on other planets.
We have 35 residents and 60 of our team together in a town that is completely isolated. There's a plane twice a week, and there's 1,000 polar bears nearby.
This is Doug Rowland, a NASA scientist who's taken his team to Ny-Ålesund on the island of Svalbard. The island lies beneath one of two regions near Earth's poles called the cusps. It's where we can access space directly, and where 100 tons of atmosphere escapes into space each day. This escape gives clues to how long an atmosphere will last, and ultimately, whether it stays around long enough to sustain life.
What we're trying to understand is, how did Earth's atmosphere evolve over time? And how do other planets that might be like Earth or more dissimilar to Earth, how did their atmospheres evolve?
So Doug joined forces with Göran Moen, a professor at the University of Oslo, who started the Grand Challenge Initiative CUSP. It's an international mission to launch 12 rockets into the Earth's northern cusp. And Doug, he's the mission leader for the first 2 rockets of the campaign.
We don't want to waste our rocket, because it took us 3 years to make the rocket and only 15 minutes to use it, and I don't want to waste my shot here.
He's using a sounding rocket, which is different from the bigger rockets that carry satellites and humans into space. It's a small suborbital rocket that flies briefly into space, collects real-time data for around 15 minutes, then falls back to Earth. It's affordable, quick to build, and can launch towards a precise point.
The major advantage is that you can launch into a target on the sky.
But there's a limited launch window and only one chance to get the launch right.
We have these unguided rockets. They go where you point them, unless the wind is blowing, because the wind literally just blows them over. We don't launch when there's high wind.
So to measure the winds, they launch balloons with GPS trackers. They're released every 15 to 30 minutes, and then they're monitored to see how fast the winds are carrying them.
The ground winds were 12, 13 meters per second, gusting 17, which is way off.
You're filled with trepidation. Oh my gosh, this thing that I built, is it going to work after all this? So I think we're going to scrub for today. I'd like to thank everyone. I think it was a great performance. Thanks a lot.
This means that we are scrubbing this operation for today, and we'll try again tomorrow.
The mission is named Visualizing Ion Outflow via Neutral Atom Sensing 2, or VISIONS 2. In short, they're looking at how oxygen is getting enough energy to escape.
It's a good test of how atmospheric escape works. Earth's gravity should hold onto the oxygen, and yet we see this gas shooting off into space. We're trying to figure out how that works.
That is a science question that has been hanging around for 4 decades.
Fortunately, anyone can see atmospheric escape at the right place and time.
In Svalbard, we have the so-called polar night. It's dark all 24 hours.
This continual darkness is key for witnessing this. This is the cusp aurora. It's a type of northern lights that appears between 8 a.m. and noon, and you can only see it when it's dark during the day. It looks similar to the aurora that occurs at night, but when these iridescent colors dance at this hour each day, 100 tons of oxygen escapes from Earth's atmosphere into space.
This is our sport now to chase the aurora.
Working with them is the ISCAT radar and Kjell Henriksen Observatory. They have additional instruments to find the aurora.
Sometimes it's cloudy, so we use radars to track the cusp. We can give advice that this is the right type of aurora.
This is the Wall of Science, a collection of data from satellites and ground instruments that helps them predict where the cusp aurora will be.
So the cusp actually isn't a fixed point in space, it kind of moves around.
What's controlling the cusp's movement is the sun interacting with Earth. Our planet is surrounded by a magnetic field that helps us hold on to our atmosphere. But at the north and south poles, the magnetic field bends inwards, creating a corridor between Earth and space.
When energy is released from the sun via a solar flare or coronal mass ejection, all of that energy in the form of radiation rides down the magnetic field lines of the Earth and is transferred and dumped into the Earth's atmosphere.
Electrons cascade into Earth's atmosphere. They accelerate and collide with oxygen particles, giving them energy to release light and sometimes enough energy to escape. Collectively, this forms the cusp aurora and streams of escaping oxygen.
This cusp is in constant motion.
And we've got a fixed trajectory. We really can't aim at where the cusp is. We have to wait for the cusp to come across our line of sight. Can you guys hear Chelmar? We'd like you, as soon as you see an indication the cusp is moving close, to move it, the radar dish, if we can.
This is IceCat. It's been very quiet, very difficult to launch.
Do you think we're gonna launch today?
No. Probably about a 60% chance of launching.
When we started seeing this really good data, this clock started counting down, and that's when everyone realized this is going to happen. We're going to launch.
We're doing everything we can to get that launch off before the aurora goes away. It is really, really challenging and nerve-wracking at that point. You can see the tension just rise in everybody when that happens.
And so everyone's watching their instruments, getting really excited, and then at T-minus 1 minute, all of us ran out to go see the launch happen. And then we immediately turned around and ran right back in to look at all the data that was coming back from the instruments. You know how much time and effort went into it because we all worked on it, and there's just nothing that compares to that feeling.
Everybody in every one of those little places, really just so happy to contribute to getting this science. It's really an incredible experience.
This is a story about what it takes to launch science instruments into space, but the real adventure will be in the data they sent back. Hidden within the numbers will be answers that reach far beyond Earth, shedding light on how atmospheres throughout the universe change, evolve, and perhaps support life.
We're going back to Mars.
That's right. NASA is sending a new rover to explore the red planet. And after a 7-month journey, it only takes 7 minutes to reach the surface.
The landing site is Jezero Crater, a giant basin that once contained water.
Our new rover's name is Perseverance.
Perseverance will search for signs of ancient life
and collect samples for possible return to Earth.
This time, our rover will not be alone.
Nope, they brought a friend, a little helicopter named Ingenuity.
Ingenuity will test the first powered flight on Mars,
which could assist future Mars rovers.
On July 30th, join NASA in wishing Perseverance
and Ingenuity bon voyage
on their exciting adventure to Mars.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We're ready for the event.
All right. In that case, Kelly and Mark, good morning. This is Mission Control Houston. Please call the International Space Station for a voice check.
Hello, guys. Good morning.
Testing is second. This new dose.
You hear us?
Good morning. We hear you loud and clear. Welcome aboard the International Space Station. And first, let's start out by saying how sorry we are to hear about Regis's passing. Our hearts go out to you and the entire staff of the show.
Thank you so much.
All start.
Okay. Here we go. Stand by, you guys. We got 81. 81. 3, 2, 1. Roll up.
5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX. Godspeed, Bob and Doug.
It is never not impressive. That was the SpaceX Dragon taking off. It is, we both have goosebumps. We're about to do our first ever interview from space. Joining us will be NASA astronauts Doug Hurley, Bob Behnken, and Chris Cassidy. They're all on board the Dragon right now, so let's get started. Station, this is Live with Kelly and Ryan. How do you hear me?
Live with Kelly and Ryan. This is Chris, Bob, and Doug. Welcome to the International Space Station. We have you loud and clear.
Wow.
How is it going up there? This is the most nervous I've ever been doing an interview. How are you?
Well, you're doing great, Kelly. Keep it up. We'll talk to you gladly. But we're doing fantastic. We've had a wonderful 2 months together as a three-person crew. It's sad for me to see Bob and Doug depart this weekend. We've got some weather that we're watching, so God willing, they'll get off on time. But we've had a fantastic stay together.
So you're going to stay for another couple months. They're leaving, but you're going to stay on board.
Yeah, that's right. I arrived in April with 2 Russian cosmonauts on a Soyuz, and we were here for a few months before Bob and Doug arrived, and we depart in October. And it was really quite special to fly right over the Kennedy Space Center 2 minutes before they launched, and to know that they were making a beeline to rendezvous with us the next day.
I'm noticing this little sparkly dinosaur floating in the foreground there. That's very cool.
Oh, wow.
Never gets old.
Oh,
Never gets
man.
old. So since there is no gravity, obviously, how are you staying so still?
Well, Kelly, it's a good question for us, and we've got our feet locked into some foot restraints on the ground, and so you can see if we don't lock ourselves in, we'll just float right away. So we've been practicing that for the last 2 months, and Doug and I just about have it down as well as Chris does. Of course, he's been here a little bit longer. And you mentioned our little dinosaur, the little Apatosaurus that our sons selected for us to be able to demonstrate zero gravity even when we were locked in, had our feet locked to the floor or locked to the seats as we were headed uphill in Dragon.
You know, nobody's kids think that they're cool, but I bet all of your kids think that you are extraordinarily cool. I have to ask, because these are questions that we keep getting asked by everyone. How do you go to the bathroom when there is no gravity?
Well, that is a question we often get, and I think the best way to answer it is it takes a little more time, and you have to be very.
But what exactly is the job of that group that's, walking on foot in front of the rocket?
Yeah, so there is a lot of folks involved in the procedure to make sure that, for example, when they came out of the tower, to make sure everything cleared properly, they double check everything. There's a safety team that looks at all. There's folks that walk alongside the MLP to make sure that the MLP itself and the trucks that are pulling the MLP are operating correctly in the train crew. And then, of course, there's just a group of folks that we have honored for this mission who have done a lot of work, from the scientist team to the engineering team on both LSP and spacecraft and ULA side, who were selected as an honor to walk along the vehicle this morning, along with Mr. Bridenstine, Tori Bruno, CEO of ULA, and Dr. Zerbukin from NASA headquarters. So that's just a kind of a special thing we do to honor some folks who've put a lot of effort in and give them a chance to see the rocket that they've been working on over the last 5 to 7 years.
Mick, one thing, we have people not chiming in, but viewing from all over the world NASA Edge, watching NASA Edge today in this coverage. And wanted to know if you could give them a howdy ho, how you doing, to all of the people tuning in to our broadcast today.
Hey, good morning, y'all, from Florida. Awesome that you're on board with NASA Edge this morning. These guys are awesome for everything inside and outside of NASA. You guys do a great job of keeping everybody engaged, and I appreciate it.
I tell you what, Mick, thanks so much. And as we're seeing these great visuals of the rocket, we keep seeing a great visual of you. It looks like you're in a suit, which is I almost never see you in a business suit. So we're getting a visual treat all the way around this morning. Very impressive.
Appreciate that. Hey, I got that number for you, by the way.
Oh, very good.
Lift capability of an Atlas V to low Earth orbit is 18,800 kilograms.
Nice.
Which is roughly 41,000 pounds. So it can lift quite a lot.
That's impressive, Mick, because I was going to challenge you on the metric conversion just to watch you dance a little bit, but you beat me to it. Very, very impressive.
Yeah, I have one of our flight analysis guys out here with me this morning. His first time ever seeing an Atlas V rocket. He has done a lot of work on the Mars mission, and so we got him out here to see what he's been working on. So he just provided me with that answer. So I appreciate Philip Hargrove and the Carney analysis team from LSP.
So Mick, at what point does LSP turn over the keys or the operation to the Mars 2020 team?
So we will do that right after spacecraft separation. When the spacecraft acquires its signal, JPL and the Mars 2020 team will take over. Our job, from getting them to where they need to be from a rocket perspective, is complete. However, we will continue to follow the mission for the next several hours to make sure that they get acquisition at their ground stations and with the Deep Space Network. But they pretty much take over once they get their signal acquisition after spacecraft set.
Again, it was just very, very impressive. I'm sorry, I'm getting mesmerized by the visuals on the rollout this morning.
Yeah, they had to stop, and they just cleared the VIF, and they stopped to make sure they looked at everything, make sure everything's disconnected and they're not still tethered to the VIF in any way. And I just got word that we are continuing with roll, so we should see the Atlas rocket start rolling here and moving up the slight hill to Complex 41.
Mick, when it arrives at the at the launch pad, what is the transition time? I know a lot has to happen before you've basically checked out and indicate that you are ready for launch. But what kind of time frame is that? Because as I said, normally you go out 24 hours in advance, so you've got to have plenty of time to do that. What's the timeline on that?
Yeah, it takes the team anywhere from 4 to 5 hours once the vehicle is down on the stanchions at the pad to get everything connected and ready to go. They've got to put the commodity auto couplers in. They've got to hook up the ground electrical. They've got to hook up a lot of things to get ready for launch. Because once we get to the pad, the only communication, if you will, with the rocket is via the pad systems that are here from the ASOC, the Atlas Spaceflight Operations Center, where the launch team usually sits. So they control everything from a couple miles away. So they have to make sure all of that is connected and follow the procedure and take their time. So once the vehicle's at the pad and down on the stanchions, the team will take anywhere from 3 to 5 hours to finish up all that work, get the environmental control system hooked up, make sure that everything's flowing properly and the temperatures and environment are right for the spacecraft.
Now, Mick, we've been out, as we've said before, at quite a few launches and covering rollbacks, and we've noticed that some rollouts are quicker than others.
Sorry, I didn't know where you were going, but that is hilarious. I was like, yeah, some of them are a lot faster than others.
What would cause that difference in speed to get from the vehicle integration facility to the pad?
I'm sorry, I was still laughing at your stumble.
I know. No,
it was an interruption.
Were you saying they roll to the pad or we stumble to the pad?
No, we don't stumble to the pad. We trip to the pad.
Yeah. No, we don't trip. We roll. No, it depends, Franklin. Each launch vehicle is unique in its configuration. As we talked earlier, this is a 541. The Atlas rocket can be configured as a 511, 521, 531, 541, 551. So depending on the configuration, we also have a 4-meter fairing configuration instead of a 5-meter. So depending on the configuration, there are different tasks that have to be completed and how long the procedure takes. So this being a 541, which is basically the only other configuration we can do is add another solid to this 551. There are a few more tasks that have to be done to make sure everything's secure before we start rolling. So that's why it took a little bit longer to get started. Plus, we ran into a few issues this morning, but it does take a little bit longer based on the configuration. But once they start rolling, it's about the same time to get to the pad, 20 to 30 minutes for each mission.
Mick, we're seeing on the aerial view here, you can see a nice image of the top of the rocket, and you can see a list of decals from the top down, starting with NASA Meatball. Is there a special configuration or process that we use or priority for those decals or stickers? Or I guess they're not decals and stickers. I'm thinking of the kind of rockets that I get to work with, which are models.
So actually, where you are correct, they are decals and stickers. Okay. They are actually special decals that are created that will actually, they are in strips as they're put on. And as the rocket ascends through the atmosphere and we pass through max Q, they actually rip during the time. So we try to make sure that happens so that nothing interferes with the aero forces on the vehicle. But the decals are actually made to rip off. But they are a decal material. And for NASA missions, usually the meatball is the first one on top, same as if it were a commercial or Air Force mission. They would put the customer mission first, and then you come down through. You have the ULA, and you have the mission patch, which in this case Mars2020, and then you have the United Space Force. I got to get used to saying that. United States Space Force, and then ULA sticker and a bunch of others. Sometimes they will also have stickers just below the fairing on the Centaur stage for dedications or commemoratives of launch team members. I am not sure if we have any on this vehicle or not, but
yeah, very prominent position. No, but it really
just be clear. I won't do that.
Yeah, of course not. And it is, but I bring that up because it's a good reminder. You've mentioned so far the amount of time that's involved from the planning of these missions, talking years ago when this is developed. So it's also a lot of partners, a lot of participants beyond NASA that make all this come together. So it's not just an interesting, visual thing for the rocket. It really represents not just the time that's been put into this mission, but the vast number of people and partners that have come together to participate in this. And that is just kind of a special thing.
Yeah, absolutely. It takes a lot of people to do this. Starting at the top, right? What we're here for is our spacecraft customer. The JPL folks in this case with Mars2020 started this science several years ago, and they got this together, and then they're trusting LSP to pick the right rocket for them, and we did, and we're working with ULA to make sure all this is mission success. So it takes a lot of people to pull this off, and it is a great collaboration and partnership between everybody to make a mission success.
Mick, we have another question that came in from Facebook about fueling. I know we talked about it a little while ago, but this question is to how far in advance to the launch is final fueling done?
So actually the countdown for an Atlas V, we will start cryogenic tanking at roughly 2 hours prior to liftoff. We will finish off fueling in the T-4 hold during that hold, and there's about a 30-minute hold there that the team will top off the vehicles, basically get it from 98% to 100%. So that 2-hour time period is when they're doing all that tanking of liquid oxygen and liquid hydrogen.
It's one of those things, Mick, where it seems like it's just a very dynamic process, that there are lots of things that have to happen in concert with one another. So you hear this process and you think, you wonder why we have delays sometimes, but with all that going on, maintaining that order of operations has to be critical as you approach launch, which I guess is why they have the holds.
Absolutely. In the case of Mars 2020, we will have two holds, two 30-minute holds. One will be at the 2-hour and 30-minute mark, where the team will verify that they have checked out all the electronics, made sure all the avionics and everything are ready to go, and that they are ready to get into what we call cryogenic tanking. Once they give a go for cryogenic tanking at T-2 hours, the team will start tanking liquid oxygen and liquid hydrogen into the first stage and second stage of the rocket. And then through that 2-hour period, while they're doing the tanking of the vehicle, the rest of the team, pneumatics team, avionics team, electrical team, they're doing all their job, checking everything out on the vehicle. The GNC, guidance and nav team, is loading up the Adjust, which is the flight software to make sure that we hit our mark for orbit. So there's a lot of stuff going on during that time, a lot of team effort in parallel work that is happening in that countdown.
Mick, just looking at the rocket as it approaches the pad now, we're seeing in the foreground and the background the lightning protection system.
Yes, sir.
Can tell us a little bit about the importance of the lightning protection system for the rocket as it approaches the pad and up through launch?
So yeah, being here in the lightning capital of the world, we want to make sure that once this rocket gets out to the launch pad, that we protect it from all things, especially environment and weather. We can withstand rain up to a certain point, but we cannot withstand a lightning strike that would damage the electronics and the guidance and nav avionics on board. So the lightning protection system, that's the catenary system that's around the pad, helps to dissipate and make sure that we do not take lightning strikes. It allows us to also measure lightning strikes if they happen to be nearby or close, that we can determine if we have to do a retest on the vehicle or if something else has to be done. Guys, I'm going to tell you, I'm real excited right now. Franklin, I am standing right here in front of this rocket in the center of the road. And, buddy, I miss you here. This is a great sight today. And it's getting ready to roll right by.
Man, I miss being there with you because, that was our spot. We were hanging out. It was like a party.
Yeah, we're a little closer today. You can probably hear in the background the rocket rolling by right now.
Don't rub it in.
I'm going to tell you guys, every single time I'm out here, I forget how massive these things are, even though we get to work with them every day. Seeing it up this close is just, oh my gosh, this is so exciting.
Mick, it's really good to hear that in your voice because I'll be honest with you, so often a lot of things like spacecrafts going to Mars is a pretty abstract process. I mean, we kind of think about it and we're impressed by it. But when you see this stuff up close happening in front of your very eyes, it just makes it real in a way that it's hard to express. And so even hearing the rocket now, I'm getting chills thinking about the rocket that's going to take Mars 2020 to Mars, and you're there in front of it. Thank you so much for doing this for us, for being there and reporting on it. It's incredible.
Well, guys, thank you very much. I love doing this with you guys. Like I said, every time I'm out here, it's exciting. And you can hear the rocket is right in front of me right now, and the trucks. Yeah, sorry, Franklin. This is awesome, buddy.
Hey, that's okay. That's okay. Mick, there's probably another 10 minutes until the Atlas V reaches the pad. I want to ask you a question quickly, just shifting gears just a little bit, to ask you about how is LSP supporting the Artemis program?
So yeah, we're working with our friends in Artemis and Gateway in the deep space logistics area. Since they're going to be using commercial launch providers, they have reached out to us as the experts in the agency on the commercial providers. So we're providing them some vehicle insight and analysis support as we would normally do for a LSP mission, and it's been exciting to work with them so far. We look forward to supporting that program and getting NASA on its way to the moon and Mars.
You know, just hearing you say that, Mick, it just kind of dawned on me. It's very exciting here for Mars 2020, but to think that you might be in the process of selecting rockets and launch vehicles for the humans returning to the moon, first woman and the next man, that has to be an incredible privilege and responsibility. I mean, I know you feel it for Mars 2020. This is going to bring back some incredible science. But looking ahead, there are just lots of great opportunities for NASA in the future. It's got to be exciting.
Oh, absolutely. NASA is doing some great things, not only with the Mars 2020, but, you know, the Demo 2 mission that launched with the crew coming back in a couple days.
Yeah.
That is a historic thing for us, being part of that mission, also working with the Falcon 9 and all of our future missions coming up. You know, one of the unique things in LSP is we are always busy. People sometimes only get to see the end mission like this, Mars 2020. But just because we're launching Mars 2020 on Thursday, we're still working 50 or 60 other missions that are going to be happening in the next several months or years. So we are constantly working new stuff for the agency, and that's just exciting for us to be part of that and that historic things that NASA's doing.
Mick, speaking about those other and future missions, what type of new launch vehicles are coming online for the future?
Great question.
Yeah, we're actually working with some commercial partners out there. A few that you might have heard of. A company named Blue Origin with their new Glenn rocket. We're looking at that. There's some smaller companies out there. You've probably seen our VCLS launches on Rocket Lab's Electron. There's some other companies that we're targeting and doing some work with in the Firefly area and other things like that. So NASA LSP is definitely working with venture class rockets, smaller rockets, and also larger rockets as we bring them on board, what they can do to support NASA's missions. As I said, it's a competitive market out there right now, and NASA LSP is always looking at what's in the future and what can be used to best support the missions for NASA.
And I got to tell you, Mick, as exciting as all that is, the visual we just saw going up the ULA mobile launch platform with the ULA building in the background, it's also great to know that the partners that you've worked with over the years that have this legacy going to Mars are also still making more rockets and launch vehicles to serve NASA and the public for years to come.
Yeah, absolutely. ULA is designing a new rocket called Vulcan Centaur, and they'll be bringing that online in a couple of years, and what they can do to not only support the commercial business, but NASA and the United States Space Force. So SpaceX, ULA, all of them continue to support all the missions that are needed. So we're very thankful for that.
So, Mick, I know that access to the Kennedy and the Cape has been kind of shut down because of COVID. So I'm asking you, where is the best place, what vantage point is the best place to view this launch down there in Florida?
There's several places here in Brevard County, right along US 1 as you're heading towards Titusville. There's some city parks right there that look right across the river, the Indian River, right into the vertical assembly building, the VAB, where the shuttle was processed, where SLS will be processed. And then looks just past that building, you'll see the Atlas V Complex 41 area here. There's also some areas along US 1 heading south towards Melbourne There's the Jetty Park area over in Cape Canaveral. There's a lot of places you can see the launch from here. It's one of the beautiful things about living here in Brevard County is you can watch rockets launch almost every week.
On a clear day, how far away can you see the rocket launch?
That's a good question. I got to be honest. I don't know because normally I'm inside the launch control room, so I normally watch it on video. My answer to you, Franklin, would be on a clear day. You could see it in Virginia because you'll watch it on TV.
Yeah. Okay, all right.
Easy answer.
Yeah,
He's soft-shoeing us now. He's been on long enough. The easy answers are coming out. No, but it's a good point about being on console and where you normally watch these rockets, Mick, because thinking of your role, you've come out here today to talk us through this process, but what will you actually be doing for ULA during the launch? What will your role be?
So for this mission, I will actually be doing commentary for the launch vehicle. I'll be basically following the launch and for NASA TV for Mars 2020. However, my team that works for LSP, what I used to do in the Vehicle Systems Engineering branch, I will have several people on the engineering team on console, looking at the vehicle, assessing the vehicle, working with ULA and LSP together to make sure the vehicle is ready to go. And, that's a lot of fun for us to do. The only downside to that is you always see the rocket launch on the video screen on console. My first live launch wasn't until 27 years into the business that I actually got to see one lift off that wasn't on console TV. So, but it's still a lot of fun, guys.
Well,
that's our job. So.
And I would feel bad for you, but you have the awesome responsibility of launching the rocket successfully. So if you don't get to see it, at least you have this vital role that you're playing in making sure it happens safely.
Absolutely. I would say out of the whole team, one of the things that you will see on every team member, ULA, LSP, United States Space Force, is the passion from the team members. They are very passionate about these rockets and what they do, and this is what they love to do. We're all out here because we love our jobs and for the science that is done because it helps humanity move forward.
Amen.
Hey, Mick, this next question that came in through social media is kind of close to my heart because my wife is from London. Someone from the UK wanted to know if you could see the rocket fly over the United Kingdom.
I do not think so, because by the time you got to remember, by the time we leave the Cape, we are we jettison the SRBs about 2 minutes into flight, and we have stage 1-2 separation, roughly 12 to 13 minutes into flight. So we are in space at that time. So once we leave the Cape and on the trajectory that we are heading out on, we're pretty quick. We're into orbit, and you can't see much.
Makes sense. If you got to plan a trip to Mars, you got to have a good foot forward. There's no dilly dallying.
Yeah, you got to hit the gas. And just as a trivial question that we get sometimes, you guys remember the InSight launch out of Vandenberg that we did?
Sure.
On an Atlas. That rocket took 17 seconds to get off the pad. To get on its way to Mars. Mars 2020, with this 541 vehicle on Thursday, will clear the tower at 5.2 seconds.
Wow.
You ought to have the state police there put a radar on it and clock it and make sure it's obeying the speed limit as it starts its trek to Mars.
Yeah, you got it.
So, talk to me a little bit, because we just have a few more minutes until the Atlas V reaches the pad. Talk to me about the orbit that Perseverance must be placed into to get to Mars.
So yeah, as we talked a little earlier, once the vehicle leaves the pad here, we will get into what we call a park orbit around Earth, and that will be our first burn of the Centaur, or what we refer to as main engine start 1. That'll go for about 6 minutes, and then we'll have main engine cutoff 1. That will place the rover and Centaur into a park orbit around Earth, and then it will coast for about 30 to 33 minutes in that orbit as it comes around Earth. and once we get into that coast, the end of that coast, we will have main engine start 2, which is we will restart Centaur for about a 7-minute burn. And what we will be doing there is we'll be on the right side of the Earth, along with Earth and where Mars is, in conjunction with each other, that we can now push the rover for space, get it enough velocity and push it into that transfer orbit, which would now be a solar orbit, so that it can intercept Mars in 7 months. So that's what we'll do, is a park orbit, coast, and then we'll do a transfer burn to get into that transfer from Earth orbit to solar orbit.
So basically what you're saying, Mick, it's like Peyton Manning rolls out of the pocket for about 7 yards and then throws the pass, the scoring touchdown to hit Mars in February of 2021.
You got it. That's exactly what it is.
It's incredible.
Now, let me ask you about this route. Is it a post route or is it a crossing route?
It's a post route.
A post route, okay.
Yeah. It's a post route out there because Mars, at this time of year, which is why we selected this launch period, Earth and Mars are in an alignment around the sun that helps us take advantage of that we can intercept Mars in 7 months instead of they're both in the same orbit plane around the sun, so that we can do that. Otherwise, it would take a lot longer for us to catch up to Mars to do those kind of things.
That brings up a good point, Mick. When you think about all the timing that takes place on these missions, obviously, if the launch period closes, you don't have another opportunity for quite some time to go to Mars. That means when you plan this mission years ago, you have to hit your milestones because you absolutely don't want to miss this period, this launch period that ends in about August 15th, correct?
Yeah, that's correct, Blair. If we don't hit that mark, we're down for roughly 2 years before our next opportunity to launch to Mars. So you have to hit that launch period and take advantage of it. And the teams have done a great job of analyzing that and determining when and where they need to be. And this is our launch period for this year for that. So the other thing that's been done for this mission is normally on a mission, when Centaur separates the spacecraft, we would then go into a disposal burn to dispose of the upper stage. For this mission, because we have to get into that transfer orbit, Centaur and the spacecraft, Mars2020, will be on the same line of trajectory. So what happens after separation is the Centaur will do a blowdown maneuver and a what we call a CCAM, a contamination and control avoidance maneuver. And the JPL folks have figured out that if we point Centaur in a certain direction when we do this blowdown, we will be able to put Centaur into an orbit on its way to Mars, but it will not intercept Mars for the next 50 years. There's no way that the Centaur could interfere with the mission in the next 50 years.
I got to just chime in and say how grateful we are for the work they're doing out at JPL. I mean, that's some important and critical work, and obviously some really good thinking that they put into all levels of the mission to make sure they have mission success. It's all across NASA, but in this case, for this mission, you just see their work shine so clearly.
Yeah, absolutely. The folks at JPL do a great job with this. Like I said earlier, it's a great collaboration between everybody to make this mission happen. And, we're all working towards the same goal, and that is mission success with Perseverance.
That's a beautiful job.
I'm just amazed at this video that the TRAS team is supplying for our coverage today. We see the vehicle assembly in the back. We see the Atlas V approaching the pad here, almost there on the mobile launch platform, and it's just amazing.
It's like, I'm sorry, several times I've been like, Mick, you got to answer that again. I wasn't even paying attention. It's just stunning visuals. You'll love it.
The pictures are better than me talking. That's good.
No, it's not that. It's just, boy, it's overwhelming. I mean, you don't usually see the aerial view at this stage. We get a lot of ground cameras, and so that unique view kind of takes you by surprise. And interestingly enough, a comparison I didn't realize, we're getting some interesting aerials of Rollout that we've never gotten before on a mission that's going to have aerial views of the Martian surface that we've never seen before with the Mars helicopter.
Yes.
I mean, you know, this is essentially what they're going to do once they land on Mars, is fly a helicopter around and get some incredible visuals, which is going to blow everybody away.
Hey,
Mick, absolutely. Looking forward to those.
Sure.
Mick, a couple more questions from online. What time is liftoff? And number two, can any part of this launch be seen by the astronauts on the ISS?
Ooh, great question.
Oh, that is a great question. The first one is liftoff will be Thursday at 7:50 a.m. That is the opening of our window that we are shooting for. We have a 2-hour window, and we have 25 attempts inside that window. So we're gonna lift this thing off at the first attempt at 7:50 a.m.
Awesome. I love the confidence, Mick.
Yep, Mick, another question, and I think some of this is sparked by the type of work that SpaceX is doing, but is there any chance that the Atlas V can be turned into a reusable rocket?
There are some, I would say that ULA is definitely looking at future possibilities of their rockets. I can't say whether they're looking at Atlas V or another design, but SpaceX has definitely changed the way the industry thinks about what we refer to as expendable rockets, and with their reuse that they've been doing. And so here in our business, it's a brand new day looking at how you start reusing vehicles.
To me, it's also it's really inspirational to see like other rocket providers, when someone takes a step forward and sees a new way to do something. Everybody takes a fresh look at everything they do to see if there's real advantage for them in that arena. And I just think that's good cooperation and good motivation for all partners as they look at new rockets and their current rocket fleets of rockets.
Yeah, absolutely. Companies in the early days looked at reuse with Delta Clipper, a program that didn't get off the ground that well, and all. The companies have been looking at it, but SpaceX was successful at it, and like I said, it changed the industry and the way people think of expendable rockets. So it's a great day to be in the business and see how these things change and how companies react to it.
Do you think there's any rocket that would be able to carry, say, someone like a 5'4" 3/4 co-host into orbit or into a body close to the Earth, let's say the moon or something like that? Have you heard of anything like that in the works?
Absolutely. LSP can help you define your requirements, Blair, and we can select the right rocket for you. There are several out there already that could do that for you.
Okay, I'm already working on my email.
Okay. We'll get our crew on that. It's a long process now. You send us your requirements. We're gonna have some questions for you. So it might take 7 to 10 years to get you there, but we'll make a selection for you and figure out what you can do.
Awesome.
Hey Mick, speaking of questions, they just keep rolling in from the internet. so don't get mad at me, and hopefully you can answer this question. I know you can answer this question. You guys pinpoint the date and time that rovers land on Mars. How is that done, and when is Perseverance going to land on Mars? And can you trim it down to the minutes?
Within 35 seconds.
Within 35 seconds.
35 seconds. Okay. Basically, I'll just answer it's orbital mechanics. If you are interested in how this stuff works, go out and study some orbital mechanics and how things have been done. The teams at JPL and our analysis folks here at LSP are really good at that. And the basics of orbital mechanics is you want to get into an orbit and you want to hit something out in space. So you have to then analyze all the thousands of capabilities and times that might occur and pick the ones that are. Like I said, for Mars 2020, we have a window, a period of July 17th to August 15th because of where Earth and Mars are in order to take advantage of that to get lifted off. So the orbital mechanics that all apply to that, the guys at JPL and our analysts do a great job of analyzing the thousands and thousands of Monte Carlo work that gets in there.
So it looks like Blair and I have to go back to school for quite a few years.
Well, you can, next time you're down at KFC, I'll introduce you to some of our flight analysis guys, and you can take their 2-day quick orbital mechanics class.
Actually, we wanted to talk to you about putting together a LinkedIn learning session on orbital mechanics. We can shoot the video, and hopefully Franklin and I can approach an understanding
through osmosis, just by being in the room.
You know what we could do? I'll get Philip to work on it. We'll take the requirements for a 5-foot nothing payload that weighs about 98 pounds.
Soaking wet.
We'll figure out some orbital mechanics for that.
Okay. All right. Now you'll put that whiteboard to good use. That's for sure.
Exactly.
And
so that was honestly that was a good question, and
yeah.
I would tell the people that are out there that are interested in that kind of stuff. That's the kind of work we do, and going to school and learning about orbital mechanics and aerospace. If that's what you're interested in, man, we can use some good people like that in the business.
Awesome.
That's awesome. As we're coming down to the close of our coverage here of the rollout of the Atlas V, I got one more question from the internet. And Mick, what does Mick feel will be the greatest achievement for this rover?
I personally feel, from my perspective, the biggest achievement we're going to get from, actually it's a couple things. I can't really pick one, but it's going to study ancient life on Mars, right? That's so exciting to me. I want to see what we can get from that and do. The other thing, being an engineer, electrical engineer and aerospace background, I am so jazzed about this Ingenuity helicopter and what we can and can't do on Mars with a small helicopter. Like Blair said, it'll be the first time that we will be able to cover a lot of distance and work and look at the Martian surface from that aspect. So I'm excited about both of those. I think that will be a huge thing that Mars 2020 can do for us.
Absolutely. And the great thing is that everything that we learn on the Mars mission is actually helping us in that next step for human space exploration. So it's just, you don't always connect the dots. It always seems cool just to watch the accomplishment, but it's comforting to know that there are people out there at NASA that are taking this information and actually moving us closer and closer to that eventual setting foot on Mars, which I got to say, I hope it's sooner rather than later. It's very exciting. I know it's super challenging, but it seems like every time there's a big challenge for NASA, they find a way to step up to the plate and hit it out of the park. Sorry to switch to a baseball analogy when we were talking football.
Blair, I totally agree with you. And one of the other big things at Mars 2020, NASA's already looking at sample return from this mission, right? Yeah. We're going to take some samples and our next step of how we get those samples back to Earth for study. So, as you said, I hope that happens very shortly so we can see that happen. But it's an awesome opportunity also for the next generation of students and people who are coming out of college or who are coming into careers that are helping us move forward. It's that next generation that's going to help us push a little farther.
Yeah, that's well stated, Mick. And I tell you, when Jim Green was on talking about the sample returns, I mean, they're going to, as I understand it, they will actually take samples and prep them for a future mission that hasn't necessarily been set yet. But that it's that kind of forward thinking that just opens opportunity for new missions and new capabilities, new innovation. And as you alluded to, a new, growing, thriving workforce. Very exciting to be part of this mission. Certainly exciting to be a part of what NASA is doing along with its partners.
Absolutely, Blair. I couldn't have said it better myself. It's always great to be part of history and what we're doing next.
Yep. I tell you what. So as we're looking at it now, it looks like the rollout is finished. Is that true, Mick?
Yes, they're actually getting ready to put the MLP down onto its stanchions, and then they'll start the environmental control system hookups and ground hookups. But they are done with roll. The vehicle is at the pad, and they are finishing up the rest of the procedure, which will take them about 3 to 5 hours to finish up stuff, and then we'll be ready for launch on Thursday morning.
I tell you what, thanks so much, Mick, for not only for joining us. You pulled double duty today. You stuck on the program when we were in a delay and had to move through this process and wait for things to get rolling again. We really appreciate all that you've done for us. Obviously, we love the coverage that you provided out there during roll. We look forward to watching launch coverage on Thursday morning and joining you and Joshua Santora as you take us through launch commentary. Best of luck, and we'll talk to you soon. Good luck, and go Mars 2020.
Absolutely, guys. Thank you for having me. It's always a pleasure to work with you gentlemen. You guys are a top-notch class act, and continue doing what you're doing to inspire the next generation and share all things inside and outside of NASA. Thanks again for having me.
Awesome.
Great stuff.
And we love working with Mick. I mean, what a treat. What a brain trust.
Yes.
I mean,
yes.
Just incredible.
Man, I just wish I could be there. Seeing it, the rollout from the ground where Mick was is one thing, but to see these shots that are being provided by T-Rats, the aerial video, is absolutely amazing because we haven't always had that.
Absolutely. A big shout out to Mike Downs and his group that have provided this footage. They're providing it now. I was going to try to convince everybody I was controlling the drone, but it's foolish to do that. That group, Mike Miller and Isaac and Jamie, all those guys, they do incredible work. And they've provided great footage for us this morning. The main thing we want to remind everybody is get ready for Thursday. There's going to be extended coverage on NASA TV beginning Thursday morning. I am not sure of the exact time, but the launch is 7:50. I think it's a 2-hour program. I'm not sure on that, but they provide plenty of coverage. Check the website because it's going to be a big, impressive launch. And then, of course, after we all celebrate the launch, we're looking forward to a safe arrival in February of 2021. Right now, for us, that concludes our coverage. You're watching NASA Edge.
An inside and outside look at all things NASA.